Mathematical Language and Symbols by Mr. Mario D. Ibalida. Language. So according to Google, the principal method of human communication consisting of words used in a structures and a conventional way and convey by speech, writing, or gesture. Mathematical language. The language of mathematics or mathematical language is an extension of a nature language that is used in mathematics and in science for expressing results with concessions, precisions, and unambiguity. Symbols. So according to Google, a mark or a character used as a conventional representations of an object, function, or process. Example, the letter or letter standing for a chemical element or a character in a musical notation. And next, mathematical symbols. A mathematical symbol is a figure or a combination of figures that is used to represent a mathematical object, an action on mathematical objects, a relations between mathematical objects, or for structuring the other symbols that occur in a formula. Mathematical logic is the study of formula logic within mathematics. Major sub-areas include model theory, proof theory, set theory, and recursion theory. Research in mathematical logic commonly address the mathematical properties of formula system of logic such as their expressive or deductive power. However, it can also include uses of a logic to characterize correct mathematical reasoning or to establish foundations of mathematics. Subfields and scope. The Handbook of Mathematical Logic in 1977 makes a rough divisions of contemporary mathematical logic into 4 areas. So we have set theory, model theory, recursion theory, and proof theory and constructive mathematics considered as a part of a single area. So here are the definition of 4 divisions of contemporary mathematical logic. So the first one is the set theory, is the branch of mathematical logics that studies sets which can be informally described as a collections of objects, although objects of a kind can be collected into a set. Set theory as a branch of mathematics is mostly concerned with those that are relative to mathematics as a whole. And number 2, model theory. It's the study of the relationship between formula theories, a collection of a sentence in a formula language expressing statement about the mathematical structure, and their models, those structures in which the statement of the theory hold. And the number 3 is computability theory, also known as recursion theory. It's a branch of mathematical logic, computer science, and the theory of a computation that originate in the 1930s with the study of computable functions in Turing degrees. And lastly, proof theory is a major branch of mathematical logic that represent proof as a formal mathematical object, facilitating their analysis by mathematical techniques. And next, the history. So mathematical logics emerged in the mid-19th century as a subfield of mathematics, reflecting the confluence of 2 traditions, formal philosophical logic and mathematics. Mathematical logic, also called logistic, symbolic logic, the algebra of logic, and more recently simply formal logic, is the set of logical theories elaborated in the course of the last century with the aid of an artificial notations and a rigorous deductive method. Before this emerged, logic was studied with a rhetoric with calculations through the syllogism, and with philosophy, the first half of the 20th century saw an explosions of fundamental results, accompanied by a vigorous debate over the foundations of mathematics. Formal logical system. At its core, mathematical logic deals with the mathematical concept expressed using formula logical system. This system, though they differ in many details, share the common property of considering only expressions in a fixed formal language. So under formal logical system, so we have 4. The first one is the first order logic. and it is a particular formal system of logic. Its syntax involves only finite expressions as well form formulas, while its semantics are characterized by the limitations of all quantifiers to all fixed domain of discourse. Other classical logics, many logic besides first-order logic are studied. These include infinitary logic, which allow the formulas to provide infinite amount of informations, and higher-order logic, which include a portion of set theory directly in their semantics. And number 3 under formal logical system is non-classical and modal logic. Modal logic include addition modal operators, such as an operator which states that a particular formula is not only true but necessarily true. Although modal logic is not often used to axiomatize mathematics, it has been used to study and properties of first-order probability and set theoretic forcing. And lastly, algebraic logic. Algebraic logic uses the method of abstract algebra to study the semantics of formal logics. A fundamental example is the use of Boolean algebras to represent truth values in classical propositional logic, and the use of Heyting algebras to represent truth values in intuitionistic propositional logic. Stronger logics, such as first-order logic and higher-order logic, are studied using more complicated algebraic structures such as cylindric algebras.